Hello and welcome to this webinar on continuous testing, the missing link in DevOps and CI/CD. This webinar is being brought to you by Quali as well as our partner Trace3. I'm Shashi Kiran and I'm the Chief Marketing Officer here at Quali, and I have the pleasure of welcoming Mark Hornbeek. Mark is the Principal DevOps Consultant at Trace3. Mark, a brief introduction from you.
Hey, Sashi, thanks for inviting me. I really appreciate having the opportunity to participate in this webinar and to meet you and Pascal and participate in developing this. Yeah, my own role is as a consultant at Trace3, and I'll talk about Trace3 further in a few minutes. I'm also an author of the DevOps Test Engineering course, which is relevant to this webinar. Thank you for inviting me here.
Excellent. And we also have Pascal, who's the Director of Partnerships at Quali, and who will be getting into the meat of things here very shortly. It's a pleasure to have you with us, Mark. So first of all, this is what the agenda looks like. We will introduce the topic of continuous testing. We get into what are some of the best practices of implementing it, why is it required, how does it differ from traditional testing. And then we'll also bring you a demo of Cloud Shell in the context of a CI/CD pipeline and how you can invoke continuous testing. And then we break for Q&A. So if in the duration of the presentation you were to ask us questions, you can just type it into this chat window that you see here. And we have a panel of experts within the team who will be answering your questions. I will also take some questions that come in and ask it to the panelists, and we should get some more color commentary around that. So with that, I wanted to give you a brief introduction about Quali as a company, if you're unfamiliar with us. So we are a venture-funded startup. We're based in the Silicon Valley with our offices in Israel as well as Europe. Our primary offering is really tailored to provide automation for cloud deployments as well as DevOps practices. Our flagship offering is called Cloud Shell, and what we do is deliver cloud sandboxes, and these are really replicas of production environments that can be used for a variety of different use cases. Quali is about 300 plus customers and close to 120 employees or so. And I'd like to invite Mark to give a brief introduction about Trace3.
Thank you. Yes, Trace3, we bill ourselves as a premier transformative IT authority. Basically, we're a value-added reseller, and we offer multi-systems integration and consulting services for a variety of IT practices. So one of the newer practices is DevOps, and this is one of the reasons why we're keen to participate in this webinar. We also have a conference coming up in May. Every year we offer a conference to our IT community called Evolve.
Well, evolution is what this is about, from a lot of what people have invested in to where they want to go. And it's a really good segue to the next slide that we have. So I wanted to provide some context behind why are we doing this particular webinar. As some of you might recall, we did a year-long survey in 2016 on some of the barriers that our customers are experiencing on the road to DevOps worldwide. And the number two thing that cropped up, not surprisingly, was test automation and, as a derivative, continuous testing. What we found out was most often this was either neglected or was an afterthought. And so it ended up causing issues for somebody who was not necessarily putting testing on a strategic level as they would do in the context of CI and CD. And so that's the spotlight that we want to shine on continuous testing and test automation, and see what we could do to resolve that barrier. For those of you who are interested, you can download the survey. The link is at the bottom of the slide. But that's sort of the topic we're going to be drilling down today. So why is this such a big barrier? Why is this important? And it sort of boils down to some of the business objectives that we see in the industry today. There's a huge amount of focus on digitization, move towards cloud architectures, the move towards really agility or speed, as many organizations try to align to their business goals, time to market becomes very critical. And a lot of traditional companies are becoming software companies and really trying to get on board the agile bandwagon. And when you try to go fast, there is a tendency to break things, right? And that's where quality comes in. So traditionally, you had an either-or scenario where you go fast, but you compromise on quality. Or if you're over-rotating on quality, then it's a tendency to go slow. The challenge today is how do you balance the two? How can you move fast while continuing to keep your quality profile intact? How do you reduce risk while you move quickly? And so that's where testing or continuous testing becomes extremely important as a key pivot that will allow us to move faster without necessarily compromising on quality. And this is a very key business philosophy that many organizations are trying to align to. And it helps reduce risk of architectural transformations. It helps reduce risk of new mergers and acquisitions, or really getting in front of their customers while not sacrificing on the experience of what they're delivering. So from a quality perspective as well as from a tracery perspective, this is obviously a key focus area for us. And before we jump into continuous testing, I really wanted us to take a look at the view of traditional testing today. And when we talk about traditional testing, this is where we don't necessarily have DevOps practices which are hardened in the organization. And these are well-structured, well-defined organizations that have been exposed to quality assurance principles. But some of the things that we see are really silos within the organization, both between the development and test organizations. You see development organizations, developing code and really tossing it over the fence, and there is a QA organizations which is responsible for catching bugs. We've also seen the waterfall methodology, which has been in existence for some time, and there is a cascading effect that comes in as a result. Some of these manifest themselves as longer lead times between the time that you are in a position to identify a bug and the time that you end up resolving it. And some of these might end up actually being business impacting. So that's where the risk profile also ends up increasing as a result, and then you have to go back and rework, which impacts time to market. So these are some challenges in the traditional world, and in many cases, people could live with it because there was not a sense of urgency to go through things very quickly. But all of that is changing, as you know. And maybe Pascal, you want to add some more color commentary to the area of traditional testing and what customers see as a problem there.
Sure. So what was wrong with this approach is that what you would end up doing is having a lot of rework occurring whenever bugs were found in staging, or even worse at release time by the ops team or the end users. And that means the code had to be reevaluated all the way back to the development team, going all the way again through the food chain. So thanks God these days are behind us and we are all being agile. I'll now pass the buck to Mark, who's going to introduce us to continuous testing.
Hey, yeah, Pascal and Shashi, I agree with everything you said. One of the key challenges with prior methods is that testing was viewed to be a after development activity and somewhat of a specialty, rather than integrated together with development or throughout the process of software development and delivery. Whereas with continuous testing, there's a deliberate strategy to have quality assessment occurring throughout the software development and delivery process. So instead of testing a big bang, a lot of changes all at once, you test as you go in increments, and you break down the overall test strategy into small parts that can individually be assessed, all the way from at the beginning through to through to deployment, and even beyond deployment in some cases, through different strategies. Tests are mostly automated because you really don't want to have problems creeping through that you've already got tests for, so you want to automate as much as possible. The speed of the process tends to be much faster, so automation helps with that as well, and it also allows for repeatability and scalability as well. The tool chain for DevOps is complex typically, a set of tools all the way from design through integration and packaging, delivery, deployment. How do you integrate testing into that tool chain at each stage is part of what continuous testing is all about. And the test environment itself needs to be as close as possible to a facsimile of the production environment at each stage so that you know your test results are going to be valid and comprehensive. Of course, it can't be 100%, but as much as possible, you want the test environment itself to be production equivalent throughout continuous delivery and continuous testing cycle. So overall, continuous testing is much more than a test phase. It's rather an end-to-end quality assessment strategy that occurs across the entire delivery pipeline. So one thing I've noticed as a consultant and for many years, in fact, as an implementer of DevOps and continuous testing in various roles, is a key element in DevOps success is getting the testing part right. Time and time again, I've seen where companies are struggling to get, why isn't my DevOps working right? And you look at it and you find out the testing isn't really being handled properly. It's not being looked at as a strategically part of the process. Instead, it's being looked at as, to some extent, more like the old waterfall model, where it's bolted on the side rather than being strategically integrated with the whole end-to-end pipeline. And that's the key difference in terms of maturity. At the beginning, you've got basic ad hoc tests. A lot of them are manual, maybe not, certainly not strategic across the entire pipeline. The next step is companies will typically just automate those tests, but again, they may not have been strategically thought through from an end-to-end pipeline point of view. And then you think, okay, let's integrate it into the pipeline with a framework of some kind. There are various frameworks out there, but the general idea is that you want to have a framework that can not only orchestrate, the test, but also the environment for the test, so that everything goes together as a package. And finally, once you have tests automated, it's not good enough just to automate tests and have them integrated, but to analyze the results in a way that are useful for the end purpose, which is to create a quality release and do it quickly. And finally, optimize the environment, focus on process improvements and ways to really speed things up. As you get a DevOps pipeline working smoothly, how do you accelerate that? Well, there are lots of techniques, and part of it has to do with improving the tests themselves and the orchestration methods and the elasticity, taking advantage of the elasticity of the environment. So these are just some of the points, but honestly, I see many companies still struggling back at number 2, and there's a lot of room for improvement in the world of enterprise to improve their maturity and to improve their DevOps as a result of that. So basically, what is the missing link? Why is it that these companies don't really have it together, completely for continuous testing? There are 3 dimensions in many things, but certainly they apply to continuous testing as well: the people aspects, the product, and the process. So people, I'm not going to go through the whole list here, but generally speaking, leadership needs to understand what is the value of testing. I think a lot of us went to engineering school and didn't get a lot of teaching about testing, and somehow we take it for granted, even though I think there have been plenty of studies to show testing represents more than 40% of an engineer's day, typically, in one form or another, if you count things like code reviews and various things. But leadership needs to understand that and realize, in terms of putting together a budget and helping to lead the culture, and training, offering training to individuals, and supporting collaboration to all the different departments that are involved in testing, and offer rewards and incentives. So people is the first step. Look inside. If you're not getting the results out of DevOps and you're not getting testing quite right, what are you doing about it specifically, rather than just assuming that somebody is taking care of it. The leadership has a role to play, and that's at all levels, from the executives, middle management, and individuals as well. Certainly product. One of the first questions I ask when I go into a firm is, how many of your tests are automated? What percentage? If it's 5%, then probably there's a serious issue in terms of getting value out of your DevOps pipeline. You just aren't going to get much speed if only 5% of your tests are automated. What's a good number? There's no absolute number. 100% would be great, but 80% is really good given the 80-20 rule. And there are some tests that are always hard to automate, but definitely it should be in that kind of range. And again, product budget, meaning what do you have a specific budget for tools and that are going to support continuous testing and the frameworks? Can you in fact put together a production equivalent test environment with what budget you have for each of the stages in the pipeline, or is something missing in the budget? And finally, process. So process is critical. Just because we automate things doesn't mean process goes away. I actually had an interesting class the other day. I was talking to some students, and they were saying, well, we don't need to do planning anymore because we do Agile and we do DevOps. And I said, no. You still have to have an overall strategy and a plan. Yes, you can do quick cycles that are compatible with that plan, but you still do need to have that planning in the strategy, and to again strategically place all the testing plan across the whole pipeline so that it's covered. This is just a quote that my alter ego likes to say. I think it sums up a lot of the things we've already just been talking about. The collaborative culture is in fact the door to DevOps. Without the culture in place, you're really not going to get DevOps, and that's true at multiple levels, by the way, right? Executive level, middle management, and working level. But even so, without continuous testing, you're really not going to accomplish continuous delivery pipeline. So continuous testing is, in fact, I would call it even the primary key to continuous delivery.
And this is very consistent with the results that came out of our survey as well. Culture was the #1 barrier for successful DevOps adoption, and then testing ended up being #2. So your alter ego is right on the money there.
Yeah, I saw the same thing happen at a DevOps Enterprise Summit a couple of years ago. There was the participants did a survey, and they came up with this sort of the same conclusion, if you like. The testing was the key thing that was missing. So it seems like there's an interesting recognition for it, but still a gap. It is a conundrum. And so I think webinars like this definitely add value, I hope. This slide basically talks about how it really reinforces what I was already saying, that assessments, meaning each stage in the pipeline, you may have different names for different stages in your pipeline. This is one I happen to like, but I think it's probably not that typical. Nevertheless, I believe that even the design stage produces something that needs to be tested. So anything that needs, every progression along the software development and delivery pipeline from design through to deployment, wherever you're producing something to get to the end result, that needs to be assessed. And testing is the way that is done. Whether it's testing in the traditional sense of running a script and getting a result, or any other means, but basically it's a test that determines whether or not the output of every stage is sufficient enough to be an input to the next stage, or whether it should be rejected and remediated right there on the spot before progressing, or maybe fixed later. But whatever it is, I mean, basically the idea of continuous testing is that you have a series of assessments going on, and the ultimate result that's delivered is judged based on an aggregation of all of those assessments rather than any one of those assessments. That's the way you do it with continuous testing. You don't just look at the output of one of these phases, like let's say I stuck in the middle. You'll see absent a test phase or test stage. I don't personally prescribe to the idea of a test stage, because I think testing has to do with more of, testing the output of something, a stage that produces something, and assessing it, and that's really what this slide projects. It's an end-to-end, stepwise aggregation of test results to determine whether something is ready for release. So how do you implement continuous testing? That's the million-dollar question, I guess. First of all, you need to be familiar with what I would call the tenets of continuous testing, the basic principles. If you don't understand all 5 of those basic principles, then I think that it warrants a look first. Once you do understand those principles, then you can shape your organization and your culture around those to match, and then you can shape the technology, your workflows, your process, and then technology to go with that. So integrating in an infrastructure and then actually using that infrastructure in a way that can leverage everything before it. So I'm going to go through each of these in one slide each, basically. So the 5 tenets of continuous testing. What are these magic tenets? They're not really magic, but some people, I think, misunderstand them. Shift left. What the heck is shift left? There are different definitions out there, but fundamentally, from a testing point of view, the idea is to conduct each test as early as possible in the pipeline. It's possible to run any test anywhere in the pipeline, but try to organize it so that the tests run early. Could you run every possible test at the first time you write a line of code? Not likely. There are limitations. So you can't just say, we'll run all tests all the time, but try to strategically decide when does it really make sense to run which tests, and how early can that test really be run to have a meaningful result. The test might be run again later, but at least shift as left as possible. That does require a lot of automation and some flexibility. The second tenet is to fail early. Why the heck do you want to fail at all? Well, of course you want to find problems and have the longest possible time before release to resolve them. So try to understand which tests are most likely to fail and run those earlier in the pipeline. That can be done if you really strategically think about the tests, the content, and what they're doing, and what's going through a pipeline at any point in time. Those are a lot of things, but it can be done. Again, it's a strategic approach rather than just saying, well, I have these tests and I'll always run them all the time. No. Instead, you say, well, I have this test, it does this, and if that changes, then I'll run that test. So it's a more strategic approach. Test faster. Okay, so there's a lot of techniques for running tests faster. Automation is part of it, but it can be that you have infrastructure that's elastic. You can vertically or horizontally scale the infrastructure. You can also arrange the tests themselves in such a way that they can run faster, depending on what stage in the pipeline they're running in. The fourth tenet is to focus on the most important tests and results, relevance. This, I think, many organizations don't get right. They tend to just pick a large group of tests, irrespective of what's really happening in the pipeline. If you're making a 2-line code change on a UI, on a user interface, you don't necessarily need to run the entire regression suite or even the entire soak test. Run the ones that are most relevant. But how do you do that? Well, there are techniques to do that. Similarly, when you get a lot of automated tests, you're going to have a lot of automated test results. What do you do with them? Well, you should make sure that you know who's the right person to get those particular results. So basically, relevance is to send the right results to the right people at the right time. And finally, fail often. Run tests frequently and with many different conditions. So, don't just because you've run a test doesn't mean that it isn't valuable further down the pipeline if the conditions are changing. You might be containerizing or packaging something. In theory, that shouldn't affect the test with immutability and all of these things. But in reality, with microservice architectures and so on, it's possible that you might want to make sure. That's the whole point. If you make a change to the architecture in particular. Okay. The second implementation item is culture and organization. DevOps does not mandate specific roles. It definitely talks a lot about organization and culture, but it doesn't actually say, it requires a DevOps person or a QA person to provide to run tests. Instead, what it says is that these different players should work together, and depending on who's the right person for any particular team, they're the ones that should write the tests. Developers are certainly not excluded from writing automated tests. There's, again, lots of methodologies out there we're not going to go into in this webinar, things like test-driven development and behavior-based testing and various methods for testing. But from an organization and culture point of view, the point is that everybody's responsible for quality. Good old Deming said that long ago, and it's true. And how do you get QA and ops and dev, even if those are separate roles in the company, how do you get them working together? Let the individual project teams decide who's the right person to write individual test cases and possibly run them as well. That's not prescribed by DevOps. But what is important is that it's done, and that the teams decide who's going to do it. And usually it's a good idea just to hold a checklist around to say, make sure everything is covered. There's a wide variety of types of tests. It's a long list when you really start looking at it. And just to make sure it's covered and that all of the different stages together collectively cover the change that's going through the pipeline. That's the key. Okay, process and workflow practices. There are lots of things we could talk about here. Fundamentally, though, there's kind of three types. There's business level process and workflow practices, things like even procurement. Make sure that you've got a process that has a budget for process for infrastructure and tools and frameworks, and making sure that there's enough people to operate the framework in the budget. And then there are a second class of things I'd say are, the human side, things like making sure that folks are rewarded and incentivized for collaborating and working on testing together. How many times have I seen a developer say, testing's not my job, I'll wait for the tester to do it, and then the tester finally runs the test and comes back proudly displaying a fault, and the developer says, I don't have time to work on that right now. That's not DevOps. So. And it's certainly not continuous testing. So having some rewards in place to encourage collaboration and sorting out who's really got what role is valuable. And finally, there's the technical skills, right? So training on automation and tools, things that sound, I think, maybe mundane, but are critical, right? How do you write a test case? What does a good test case look like? An automated test case in particular. Do you have some golden examples? Do you have a way of scoring a test case? These are examples that I think are of good process and workflow that help support continuous testing. You can't assume it's going to happen just because you put a framework in place, right? There are other aspects to this. Okay. So integrating DevOps test infrastructure is really critical because without having an infrastructure integrated with the DevOps tool chain, you're really not going to get any bang for buck out of the tool chain. So first of all, plan it. Make sure that you really understand for each stage in the pipeline what that infrastructure should look like, and then during the operation, actually run the tests. And I call it a master DevOps framework. There's again many words for it, but tool chain, CD pipeline, somewhere along the line there's kind of a backbone that ties it all together. Many different tools I'm not going to mention for the moment. And then finally the assessment, to run the test assessments, or running the tests and getting assessments from them to help provide feedback to each of the stages in the pipeline. There are, in fact, a critical item here is when you are integrating the pipeline and integrating the framework, you really want to have some triggers, right? How do you know when to launch tests? So that's going to be dependent on the results of both the assessment and the results of knowing what's changing as you're going through the pipeline, right? If depending on the complexity and the content that's going through the pipeline, you might trigger different tests. And for that all to be put together in an automated fashion is key. Some of the more sophisticated environments actually do this by taking a trend view of the test results, try to determine what are the most important tests to run based on changes of that, that are going through the pipeline and how they've worked in the past. But either way, it's important that you have a way to trigger the entire framework, including the tests, so that you can stand up a framework quickly and not slow down the pipeline. Once you have the tests and they've executed, what do you do with them? It's not a whole lot of value if they don't produce any specific verdicts. So a verdict is, pass, fail, inconclusive, and so on. You collect them together. You don't just, spit them out in a log somewhere. That's unfortunately typical, but it's much better if you have a collector that will, sort through the series of results over the pipeline for a particular feature, and then you can aggregate that and make a judgment at the end of the pipeline of where to go next. In fact, in a more sophisticated pipeline, I call it an adaptive pipeline. Even the pipeline itself can be adapted in future stages as it sees how the feature is evolving through the pipeline. This is particularly interesting in the microservices world, for example, where you may want to search through a dependency tree in a complex microservice environment to determine what to do next. Okay. We've talked about test orchestration and automation a lot, but it probably doesn't hurt to stop for a second just to say, wait a minute, what is the difference? In fact, does everybody know what orchestration and automation really is? So orchestration is, I kind of think of it as a superset of automation in some ways. It's not only to run something, but to actually set up the environment for running something. So setting up the test environment, physical as well as virtual, any kind of resource involved in a test, whether it's the tool or the application that's being tested, or any interconnections needed to make that whole environment work. And so to me, that's orchestration. It's the big picture of putting everything together in an automated fashion, whereas test automation itself is rather just running the tasks of testing for a particular purpose, a particular test, right, without any manual work required. So to me, test automation and orchestration are both very critical, but orchestration is kind of the broader context. So when you look at orchestration, test resources may vary depending on the complexity and risk of what's being tested, and this is where the elasticity of resources is critical. You want to be able to scale up or scale out depending on what tests are going through the pipeline, whether you do that strategically or whether you do that in advance, whether you do it dynamically or in advance, I should say. Either way, you need a flexible environment that allows that orchestration to be elastic and to be able to drive physical configurations if it's a product that does have to be tested in a number of different physical configurations or virtual configurations or containerized and so on. In test automation, there is kind of three key elements to get test automation itself right. First of all, start with the tests. And there's no much value in having the best possible test automation framework if the tests themselves are bad or if they're not going to stand up for very long. So create new tests in such a way that they're going to stand the test of time themselves. That requires some discipline and some practices. And then run the test to match the specific content being changed rather than just always running all the different tests. Again, that's another level of flexibility that requires orchestration as well. And then produce test results automatically to support the in-process assessments. So again, that requires some measure of flexibility. But this is what the best-in-class continuous test environment looks like. It's very flexible, very dynamic, and is constantly changing itself depending on the content that's going through and the test requirements for the content. To do that requires some level of sophistication. It's not just a matter of having a tool. You don't just go out and buy a continuous test per se, right? There's a lot of different components involved. If you take a kind of a stand back from the whole, if you like, orchestration stack from dev through to delivery, there's different layers. You can identify different layers. So if you like, the highest level is a decision layer, application release automation software that determines whether or not the artifacts going through the pipeline are good enough based on test assessments. ALM systems do something similar and provide visibility to what's going through the pipeline. Underneath those systems, there's a lot of automation going on at different stages. So build automation with test orchestration for development, for example. Even prior to integration, there's a lot of testing going on to make sure that the code is ready for integration, what's called pre-flight testing. And then packaging and acceptance testing, configuration management, staging, and production testing. I'm going to turn it over to Pascal because he's got a lot of things to say about this as well, and in particular, he's going to show us an actual demo of a real situation, real tool.
So first of all, Mark, I think there was a good in-depth overview of what continuous testing is about, and I like the way there is not just a focus on the tooling or the process, but laying accountability at the feet of leadership and people within the organization to make tests successful as well. And so that sort of is factored both into this stack when you talked about the decision makers, but also in the earlier slides when you said leadership to drive down this direction is very important. So with that, maybe Pascal, and knowing that this is a complex landscape, maybe you can double click on how does Quali fit in and how do you leverage cloud sandboxes?
All right, thanks, Shashi and Mark. So let's take the picture that Mark showed previously and look at the end-to-end solution, combining the power of ARA tools. And when you think about ARA tools, you think about Jenkins pipeline, for instance, or Excel release, and Quali sandboxes. So we used the Jenkins pipeline to manage the phases and gating definition of the CI process. And what we do is we map a different blueprint as you move through the various stages using our API. And the key value here is that it's the time it takes to define the environment. So we solve the problem of tool fragmentation by offering an orchestration layer on top. And we have the concept of blueprints that provides you standardization and, most importantly, repeatability. So each Jenkins job will also run a suite of tests based on the phase definition. And then it will deploy a sandbox and tear down a sandbox at each stage. So we do provide tight integration with lower-level orchestration tools such as AWS CloudFormation. You might have heard about OpenStack Heat. There is actually quite a few of them, and we provide this integration as needed. So the sandboxes may be deployed on the cloud of your choice, and we also support hybrid cloud deployment options. So it could be deployment in a public cloud, deployment in a private cloud, or deployment in a cloud that has different touch points as needed by your application requirement. The application build itself can be retrieved from a repository like JFrog's Artifactory, and we'll show that during our demo in a few minutes. And then it's automatically deployed using a configuration management framework such as Ansible, and we just released actually in Cloud Shell 8.0 full support for Ansible. So what I want to do now is review a little bit more in detail the concept of the cloud sandboxing using Quali's Cloud Shell platform. So what is a cloud sandbox? A cloud sandbox defines the environment an application tester will use to validate a specific use case. So it includes the physical and virtual infrastructure, the application workload, the data, the test tools and services, and you've probably figured out that in this webinar we're going to focus on the end-to-end picture of this application deployment and how we use the CI solution to deploy and trigger the sandbox. So what does it take to create a sandbox? So a designer or architect will model a blueprint using our UI, our web UI, and attach automation and orchestration to resources. So the system includes out-of-the-box networking for layer 1 through layer 3. And once a blueprint has been created, it can be published to a catalog and deployed to the cloud of your choice. So it could be vCenter, or OpenStack, Azure, AWS. These are all supported out of the box. Another important aspect is the added governance and control from the creation of blueprints to their activation into sandboxes. So we provide a BI tool that gives the IT or lab administrator an overview of all the resource utilization, the costs, the training for all the sandboxes that have been deployed. And finally, as I mentioned previously, blueprints can be activated through a RESTful API, which would be the case when you use a pipeline tool like Jenkins, or accessed through an end-user self-service portal. So we'll now view this concept in action through a demo from Hans, who is a technical marketing director, showing an application deployment, continuous integration workflow, including GitHub, Jenkins pipeline, Qualys Cloud Shell, JFrog Artifactory, and Ansible.
All right, so in this demo, we'll look at how the integration of Quali Cloud sandboxes with tools like Jenkins Pipeline, JFrog, and Ansible can simplify and speed your CI/CD pipeline. Now, before we see everything in action, I'll give a quick overview of the demo and highlight some of the integration points. So first, we'll show an end user, like a developer, making a code change and then checking in their code to a repository, like Git. For this demo, we'll just edit a simple index.html file, which will be the artifact we deploy onto our web server, so we'll be able to see the updated change. Now, the push to Git will then trigger a Jenkins pipeline build. So if we jump into Jenkins, we'll see we have build when a change is published to GitHub enabled. Next, looking at the pipeline section of the Jenkins config, we can see that the build stage will push our index.html build artifact to Artifactory. Then each of the following test stages will deploy an individual Quali Cloud sandbox using the Quali Start Sandbox API call that's part of the Quali Jenkins plugin. Then we'll run our test, in this case a simple test script, which will run in the context of that sandbox. If we jump over to Cloud Shell's self-service catalog of blueprints, we can see the two sandbox blueprints that will be deployed in the different stages of the pipeline. Our demo application, called Flex, is a web application with an application server, load balancer, and database backend. Each blueprint defines all the application and infrastructure resources needed to deploy our application. Cloud Shell provides a flexible, cloud and infrastructure agnostic way of deploying resources. Let's look at our web server component. In this demo, we'll deploy to VMware vSphere, but we can also deploy to AWS, OpenStack, Azure, or Docker. Once our web server infrastructure is deployed, we'll select the configuration script we want to use to configure our application. In this case, we'll use a script that will pull our artifacts from Artifactory and Cloud Shell's native integration with Ansible to configure the server. Note that we'll be using the Ansible playbook called Web Server Install. Okay, so that's a general overview of the flow and integration points. Now let's see it in action. So first, I'm going to jump over and spin up a developer environment and RDP directly to my developer machine from Cloud Shell. Though not necessary, it's extremely helpful for end users to have a single pane of glass access to all their resources. From here, I one-click RDP into my machine, and I can start coding. So now, I'm just going to make a small change here to Cloud Shell, Jenkins, JFrog, and Ansible. Then I'm going to save my file and go back and check my changes into Git and sync so that my changes get pushed up to GitHub. So now let's jump over to GitHub to make sure that those changes are live. And drilling down, we can see in index.html, there are the changes, Cloud Shell, Jenkins, JFrog, and Ansible. Okay, so since we've pushed to GitHub, that means that our Jenkins pipeline should have already been launched. Let's go over to Jenkins and make sure that the pipeline stage is starting to run. So here we see our pipeline build running, and you can see that our simple build stage has pushed the artifact index.html up to JFrog Artifactory. Now, if we quickly jump over to Artifactory, we can see that build number 59, which is the current pipeline build, and drilling down into the build artifacts, we can see that indeed the index.html file has been pushed up to Artifactory. Okay, so now the next stage, test high availability, is already running. Let's look at the output. So here we can see that Jenkins is using the Cloud Shell Sandbox plugin to deploy a sandbox called FlexTest HA59. And it's using the start sandbox call to do this. Now let's jump over to Cloud Shell, and we should see that this sandbox is spinning up. And there it is, FlexTest 59. And this sandbox is based off the Flex High Availability blueprint. Now if we drill down into the sandbox, we can see Cloud Shell running all the automation to spin up our application and infrastructure. We can see our databases spinning up, our application server, our web server, and load balancer, all being deployed onto vSphere. Now, as I explained earlier, once Cloud Shell has deployed the VMs and other resources, Cloud Shell will configure the applications. In this case, we're using our native integration with Ansible. And we can see from the output that the VM deployments have completed, and that now the Ansible playbook is running as it configures the web server application. In this case, it's pulling the artifact from Artifactory and deploying the updated artifact index.html to the server. We can easily see the update by viewing the web interface of our web server. So with a single click link to the web interface, there it is, our updated text, Cloud Shell, Jenkins, JFrog, and Ansible. Okay, let's jump back to Jenkins and see where our pipeline's at. So we can see that the second pipeline stage has completed and passed, and that the third is now running. So here, Jenkins will be spinning up a new sandbox for running some performance tests in. It should be called test performance CI_59. So jumping back over to Cloud Shell, we can see that the previous sandbox has been torn down, which means the VMs have been powered off and other resources have been returned to known configurations. And this new sandbox is spinning up. What's important to note here is that the resources in this sandbox are going to be different than and configured in a different way than the last sandbox. Since we're running performance tests, our Cloud Shell sandbox is spinning up and configuring additional components like JMeter resources, as well as multiple web servers to test a true load-balanced configuration. Again, we can see Cloud Shell deploying each application, including the JMeter resources, as well as invoking the Ansible playbook to configure the web servers. And checking one of the web servers, we can see that the index.html artifact has been deployed and our web server interface has been updated. So in this demo, we saw how quality sandboxes allow you to quickly and easily deploy powerful application blueprints for each stage of your CI/CD pipeline. And with integrations with pipeline or ARA tools like Jenkins Pipeline, artifact repository tools like JFrog Artifactory, and configuration management tools like Ansible, really makes your release pipeline faster and more reliable.
So now that we've seen the demo, the continuous testing approach takes on a special meaning when it comes to the final deployment of the application to production. And this is where the term continuous deployment will be used and abused. There are several variations of introducing new features into an existing production environment, and depending on the application, you might want to choose one versus the other. So the first one is A/B testing on the left side. It's a way to introduce an application state to a customer, say feature A, while some other times they're exposed to another state of the application, say feature B. And the information is collected on the back end. So this is typically used to compare, for instance, two versions of a web page and figure out which one performs better. The canary testing is simply a toggle that is tied to a feature and can be turned on and off so that only specific users are exposed to the new feature. And that one, we see it commonly with SaaS applications. Think about it like a Netflix application, for instance, who wants to introduce a new feature to some of their subscribers. And finally, blue-green testing is a way to deploy a new environment in parallel of the existing production environment and redirect traffic using routing or a load balancing algorithm to the new environment once it's deemed production ready. And this is where actually cloud sandboxes can be very helpful, since the same system can be used in pre-production and at release time.
So Pascal, thank you for covering that. So clearly there is relevance of what Mark talked about as well as what you shared both with the slides as well as with the demo of Cloud Shell into aspects of testing like blue-green. And it's a use case that can certainly benefit from bringing in this environment orchestration and test automation linkage. I want to summarize maybe the output of what both of you covered as benefits of continuous testing. What we are seeing is both reduced test time as well as wait time for tests, which is actually a big deal leading to productivity improvements. The second aspect is directly tied to analysis through improved test results. And again, it helps rapidly get to a point of resolution and look at which ones are business critical versus not. The third, perhaps where Cloud Shell adds a lot of value, is in rapid test environment recovery. And so the more complex the environment is, it becomes more difficult to recover it. So that's where, you know, having the ability to snapshot and model complex environments becomes hugely helpful. The fourth is tied to efficiency of shared resources. And again, both in terms of collaboration as well as the ability to bust through silos, this becomes incredibly useful. And the last talks about being able to offer improved service level agreements, which is really something you can do when you're confident about being in a position to offer it. So really bringing in continuous testing across the board is helpful both from a quality as well as an organizational process improvement, eventually leading to tangible business results. With that, I wanted to summarize what we went through in the course of this webinar. We set off with the premise that continuous testing can be a balancing act between speed and quality. You don't need to compromise with an either-or approach. And by really recognizing the fact that it is a standalone activity on its own accord, deserving its own special spotlight in much the same way as we do with continuous integration and continuous delivery, we can actually get to a situation where it's a no compromise approach between speed and quality. Second, it's important to ensure that we intertwine it in a proper way with continuous delivery mechanisms to lead to deployment principles. And this is where, you know, both leadership comes into play as well as recognizing where this fits in within the existing tool chain and to introduce it in a non-disruptive way with the existing tool chain and tool set. And third, we talked about cloud sandboxes and how they can be used to both orchestrate as well as automate environments for continuous testing. And these can be introduced with your existing tool chain like Pascal demonstrated. And at the same time, it can bring in huge levels of productivity improvements as well as speed associated with each stage of the pipeline. So in a nutshell, what we're talking about is from a missing link, continuous testing can evolve to becoming a glue between the different processes in your CI/CD pipeline. And so I'm hoping this webinar went a bit further in terms of educating you on continuous testing. And for those of you who are interested in participating in our 2017 survey, I would encourage you to click the link on this slide and participate in it. It should take a few minutes of your time, but you get the opportunity to be one of the winners of a $100 Amazon gift card. And we do this every month. And for those of you who are interested in continuing to know more about sandboxes and different use cases, I would encourage you to register for this upcoming webinar on the 26th of April. And this is really geared towards network function virtualization as well as software-defined architectures, SD-WAN, and things like that. So this is something you can register when you get a chance. So for, again, purposes of engagement with either Quali or Trace3, Mark also mentioned his association with the DevOps Institute, where he provides training courses on continuous testing and DevOps automation. These are links of our respective websites, and you can contact any of these links and try to find out more information, either about this webinar or more information about any particular activity that you're associated with. And so with that, let me open it up for questions for both to Mark as well as Pascal based on the material that they covered. Again, I wanted to just reinforce that we will be awarding certain attendees of this webinar based on a drawing Amazon gift cards as well. So up to 3 attendees will receive gift cards for this particular webinar. And the more active you are, obviously, and the more that you stay through the event, it helps. So with that, let me open it up for questions. So Mark, here's one for you. So we talked about testing fast, and we talked about quality. So what are some of the best practices for testing fast without sacrificing quality?
Yeah, you're right. We did cover that to some extent. Probably what we didn't discuss in much detail were some of the additional practices down at the test case level. For example, how you would do things like adjust timers in the test case when depending on what stage in the pipeline you're at. So in the earlier stages, timers are usually set pretty short so that you can get a result quickly, whereas in the later stages they tend to be a little longer because you're doing more acceptance level testing. So that's just one example. In general, I think we covered a little bit, but auto scaling, to be able to automatically determine what the scale needs to be to run as fast as possible. So keeping track of the speed of each test case and being aware of that, having the tools aware of that, and auto scale accordingly. So if it turns out a change is going through the pipeline that requires or could benefit at least from a scaling vertically, let's say, having a more powerful resource, then use that resource when you need to, but not when you don't need it, then you don't need to utilize that more powerful resource. There's just a couple of examples.
So it sounds like a topic for another deep dive
yes.
webinar.
Yeah.
So you mentioned during the course of your presentation that ideally it would be good to have 100% of your tests automated, but 80% is a good enough number, following that 80-20 rule. So the question here is, do all tests need to be automated for continuous testing?
Yeah, this is a very important question. How much is enough? How much testing is enough? I mean, the truth is, there's no such thing as enough testing, really. Testing is a statistical process, and there's never really 100% testing. But what level is sufficient enough to be, to mitigate any risks that might occur when you make a release? So the 80-20 rule is not a bad one. Definitely, there are some tests that you're probably not going to bother to automate. If you're creating a new feature that has many parameters, you probably will do parametric testing on all the different variations of the variables in that feature one time. But after that one time, you're probably only going to select a sample to run all those different parameters. This is another example, right? Usability tests tend to be difficult to automate. When you need a human judgment involved, how do you how do you automate the human judgment? We're not quite there yet with AI. Maybe we will get there, but having a person involved in certain tests is critical. You can cover that through the process. As Pascal pointed out, canary testing, A/B testing can allow for some human input. You can apply those techniques even within the pipeline to some extent. But those are some examples, anyways. But yeah, 80-20 rule is not a bad one. Overall.
That's a good benchmark to aim for. So here is one more on the duration of tests. I think you talked about the timing aspects and using timers. I'm not sure if this is associated with that comment, but how can long duration tests be accommodated with continuous testing?
This is a classical anti-pattern for DevOps. How do you, it's kind of the chart. I'll go back to the chart that you presented. Tests being, quality being balanced with speed.
Right.
How do you make sure that tests that can only really provide a result when you run them a long time? How do you integrate those into a fast DevOps pipeline? There are different ways. If you had an infinite number of resources, I guess you could run them all in parallel and get a lot of results faster. Sometimes even that won't be sufficient. You can accelerate testing by using certain tools that will accelerate. Let's say if it was a traffic generator, you could run to a higher performance of traffic than is typical, so you can overrun over a short duration to simulate what a long duration test might provide. If you're looking for things like memory leaks or other long duration test failures. You can also have strategies to do things like run long duration tests occasionally. So set aside, again, using orchestration, set aside some resources for certain builds that are targeted for long duration testing and run those in parallel with the pipeline. And of course, you can do extended tests beyond the end of the pipeline and keep track of things. I would say that in general, DevOps, it's really important to think of the concept of mean time between repair as much as it is mean time between failure, because that's where a lot of folks get hung up. What is long duration in the context of DevOps? Well, it's really important that the software is super reliable for the duration that it is deployed. And if you're deploying it quickly enough, then that duration does shrink, and mean time to repair becomes more important in that case. And so there's all of those things to consider.
Good. I see a few other questions here. Let's make it quick in the interest of time. So Pascal, maybe this one's for you. So how can I use the principles of continuous tests for legacy applications?
Yeah, this is an excellent question. I mean, for those of you listening to this webinar, you might wonder, does it apply to me? Am I really concerned by this? My application is still legacy, and I haven't moved on to all those fancy microservices, new style of containerized application. And I would say, indeed, it applies all the more to you. It's, as Mark has described throughout, it's not just about a specific technology, but it's also about a culture change and organizational change. So you should start with that. And even further, when you think about application modernization, you really can use the benefits of continuous testing to accelerate the modernization of your legacy application into those new future architecture.
Excellent. So Mark, you actually talked about microservices. I think it was in the context of the complex environment scaling and things like that. So how does continuous testing apply to microservices architectures?
Yeah, so that's very interesting. Microservices have risen strongly in the last few years. Together with containers, they seem to be a good marriage, but not necessarily go together. Microservices gives you the opportunity to have small, well-bounded, distributed architectures, and effectively you're now testing a network rather than just an application, because these well-bounded little, applications work together through a networked environment and their APIs. So they have to have contracts. So things like their contract It's just another form of testing. So it's really not different. It's just that you need to make sure you have them. It does allow you to organize your tests well, right? The idea of being able to select tests according to what's changing becomes a little easier because you know exactly what's changing. You know which microservice changed and select the tests that go with the microservice every time you do that. And that has an implication for orchestration as well. Select the test environment that goes with whatever microservice is being changed. With microservices, you have typically multiple parallel pipelines going on that they're all, if you like, I like to use a word that is somewhat beyond orchestration, this idea of choreography of processes, where you have a very dynamic environment and they're playing off of each other, the environments themselves. So testing the dependencies that are not supposed to be there, making or that they are working between microservices, the network reliability, and then doing smart orchestration across the whole series of microservices is critical. So the microservices introduces essentially more of the same, but also, this idea of being able to orchestrate things at a finer grain level.
Excellent. I like some of these questions. Each one of them are potential deep dive topics onto themselves. Maybe we'll wrap with this question, Mark. This one's about usability testing and how it could be handled with continuous testing.
Yeah, so I mentioned that a little bit earlier, but in general, usability testing typically requires human interaction. So there's definitely going to be some amount of manual testing that will need to be, at least the results need to be brought into the pipeline. So the verdicts need to be part of the assessment. A/B testing, canary testing provides a way to get more users' feedback. It's a critical idea that the process itself is somewhat automated, even though the hands-on is not automated. And I guess one other class of tools we really didn't talk about that are valuable in usability testing are application performance monitoring tools that can also be integrated into the pipeline, so you keep track of things like user behaviors and things like timing of different features of an application can be automated.
Excellent. So with that, maybe these are additional topics for us to cover, but I wanted to take the opportunity to thank you, Mark, for coming over and joining us in this webinar, as well as your alter ego, DevOps the Gray. Both of you did a fine job today, and we'll probably have you in for some more webinars, and this is educational material. And to you, Pascal, for the coverage that you did, as well as to our friend Hans for the demo. And with that, what I wanted to just share is if there are additional questions, please send an email to us at info@quali, or you can access us through any of these websites. Thank you for joining the webinar today. Have a good day. Bye for now.